so let's just do a recap the last couple of days. Guys, what is an ion? What makes something an ion? You're going to need to know this definition. No.
Wait, what did you say?
Natural or more elements. What makes it an ion? Okay, it's a charged atom. Okay, but what I want you guys to know is a charged atom that gains or loses, and the key here is electrons. It's an atom that gains or loses an electron. If it gains electrons, it's going to have a negative charge. That's your nonmetals. If it loses electrons, it's going to have a positive charge. That's your metals. So anytime an atom gains or loses electrons, we call that an ion. So what is an isotope? It's very similar to an ion. Yes. An isotope is formed where an atom gains or loses neutrons. You guys right there, that's a test question. This is going to be an easy test question. Explain the difference between an ion and an isotope. An ion, that element's gaining or losing electrons, and an isotope, it gains or loses neutrons. Really important there. And we can see this model down here with sodium and chlorine. Sodium has a positive charge, and the reason why it has a positive charge is because this little chlorine, or this little electron out here all by itself, sodium is like, man, I'm all happy except for I got this guy that keeps tagging along in my little group and I want him to go away. And chlorine's like, hey, I got an open slot. Why don't you give me your little guy on the outside? So it goes way over here. And now the two have bonded with that shared. Okay, and notice that what sodium did is actually gave it away. It's not sharing the electron, it is literally giving it away, completely leaving the sodium atom. And that is what we call an ionic bond. Okay, an ionic bond occurs when an electron is transferred from one atom to the other, completely given away.
We need to write that.
Yep.
An ion is transferred with what?
An ionic bond is when an electron is being transferred. Now, stop and think about this for a minute. So, how many, you guys look at your periodic tables. How many protons does sodium have? Okay, so sodium has 11 protons. How many electrons after the bond?
10.
So what's the overall charge after the bond? +1. That's why we say that sodium has a positive charge. If I look at chlorine, what was the number of chlorine or protons for chlorine? So it's 17 protons. How many electrons after the bond? So what's 17 minus 18? -1. So we say that chlorine has a negative charge. So that will help you understand this ridiculous comic. Another casualty in the war of sodium atoms.
I'm the only one that
Yeah, after sodium loses an electron, it becomes positive. Yeah, okay, whatever. Good.
I got it, Mr. Comment.
I appreciate that.
I thought it was so fun.
I was reading it.
It was the same too.
Okay, so So, you guys, think about ions. There's going to be a lot of different types of ions that we talk about a lot in earth science. The first one is going to be a silicate ion, and that is SiO4. I want you guys to use to understand when I say silicate. This is what I want you guys to think of, SiO4. It's the biggest mineral group in the world, in the universe. These make up over 80% of all minerals. All known minerals, 80% of them are silicates. The next one is carbonates. Carbonates is a lot of our ores. And that's going to be, basically a carbonate is a CO3. I think it's a -2 charge. It might be a -3 charge. SiO4 is a -4 charge. And then the last one is oxides. You guys, all an oxide is you have this lone oxygen atom floating around. It's going to be some metal plus oxygen. Okay? So, for example, you might have copper oxide. Guys, how many guys have seen green roof before? A green metal roof. Okay, you know, we start off with copper. It's this bright, awesome bronze copper look, right? And just give it a little bit of time, all of a sudden it turns to green. And why is that?
Because it gets nasty.
Yes, it gets nasty. It is a chemical change. It's bonding with the oxygen. Okay, so our free copper is bonding with the oxygen. We're getting a copper oxide precipitate that sits on top. Okay, that's called fatima or fatina. And then basically all it really is and that'll happen guys with silver, right? If you have pure silver, you might have silver like silverware or something like that, or earrings, they'll start to blacken over time. They'll get like this oily look to it.
Oh yeah, like at our work, sometimes they get gross and we have to buy all these silverware.
Well, you shouldn't have to. If it's true silverware, all you gotta do is get the polish and it cleans it off.
Well, there's so much silver at a restaurant.
Yeah, no. Okay.
So,
Yes. Because if you didn't, it would oxidize and get really ugly and black. It's exactly like rust. Okay?
that's good knowledge.
It has a black color to it. Yeah. But it's the same exact kind of stuff. Chris.
I was gonna ask for the copper oxide thing. Isn't that something that happens naturally?
Yes, that's why it's green instead of a beautiful copper color.
Really? It used to be copper?
Yes. Cameron?
Is that 4 or
4. Alright, so guys, once again, when we look at ionic bonds, so remember the two things I want you guys to know about ionic bonding is that the ionic bond is when the electron is transferred. That's going to be a key phrase, is when the electron is transferred. And this type of bond takes place between two specific types of elements. This is only going to happen if you have a metal bonding with a non-metal. So give me an example of that. What would be a metal that would bond with a non-metal? Salt, which is NaCl. You guys know when it's just Na, one Na and one Cl, we call that a binary ionic bond. It's not anything that you really need to know. But NaCl is a perfect example of that. You might also have Al2O3. Aluminum is a metal. Oxygen is a non-metal. That is a ionic bond. All right, so any questions over ionic bonds? So last thing is a covalent bond. And with a covalent bond, we're no longer transferring the electron, it's being shared. So the covalent bond is a shared bond. We're sharing that electron. And we can see that in our little upside down Mickey Mouse here with water. Notice that the hydrogen wants to have 2 electrons in its outer shell. And so right now it only has 1, and oxygen needs to have 2 more to fill this outer shell. And so what will happen here is it kind of doubles up, and it shares. So oxygen shares these 2, hydrogen shares those 2. The same thing with these over here, and it gives everybody a full happy shell. We get H2O. Now notice, if you really think about it though, that's still, this molecule is still short, just a couple. That's kind of important there. Which is why we have to add 2 H2Os in order to have this full bond. But what's also important here with covalent, it's only between 2 non-metals. 2 non-metals.
I did.
So covalent is be between 2 non-metals. So like H2O, hydrogen and oxygen are 2 non-metals. What is that? C6H12O6. That sounds familiar. C6H12O6. Nope, the carbon monoxide is CO. C6H12O6. Come on, guys. This is a hydrocarbon. A very important hydrocarbon. You need it to live. You should be ashamed.
I'm just kidding.
You seriously should be ashamed.
What did she say?
Gerson, with the biology classes you've taken, you should be ashamed.
Wait, okay, hold on.
C6H12O6.
I know the formula.
Yeah, you should. It's glucose.
Oh, shoot. I knew that.
I'm gonna go tell Snyder.
No, don't. She's gonna be so ashamed.
Oh, she will be.
And you know what's the funny thing is?
What?
Because I was studying for the test, and I was like telling Drills all the stuff I knew, and I was like, and I was telling him about this, and I told him it was glucose, and I didn't even say it then. Because I know it is. And I told him, go ask him.
Okay.
Ask him about my test that I was freaking out about. Yeah, go ask him.
Alright, I will.
Okay.
Alright, so yeah, so again, when we think about glucose, again, those are going to be covalent.